So I got an audio mixer to work on this time. This is a piece of equipment that I've owned since I guess about I'm going to say 1981, maybe 82. Yeah, probably 82, I'm thinking. I used to do my own custom mixes, and I used this mixer, and then I used it in my production studio for a number of years before I went all digital, and then it just sat on a shelf. It doesn't work. We're going to fix it. This is an old mixer that I've had for forever. Tenaphase 3 PR2700. I bought this probably back around 1980, 81, somewhere in there. I used to use this to make my mixed tapes. So that tape I showed you in the last video that had the little printed card on it, all the music was mixed through this. I had 2 turntables, and I had 2 CD players connected. I never used the microphone. I did when I was doing production work, when I was doing video production. I used to run my microphone. One of the channels of my playback machine would run through here, or I had another tape deck I could run in here. This was a mono input. I called it the lav mic. Used to use it for doing voiceovers and stuff when I was mixing. It also had a microphone that could plug in here with a talk-over switch for use as a DJ. If you were mixing music, say for a reception, you could talk over it. You could have your mic level set, and then you could be in standby mode. Flip it to normal, and your mic would operate just as if you opened a pot here to talk. But in talkover mode, flip it that way, and it would drop the level down by about 6 or 9 dB. And then you could talk over it. Normally, it would stay in the standby mode. That would be used if this had been used, and a mixer like this could have easily been used at a small radio station for 4 inputs, 2 turntables, and a couple cart machines, for example, which is what a radio station would have typically been using of the day. You'd have 2 turntables, and these ones actually were double input, so you could switch. So you could have 2 turntables with either magnetic or ceramic cartridges. This mode basically turned it into another line input. So these were the crystal input, as they called it. That was a line input, so you could actually run 4 tape decks. In my configuration, I had 2 turntables, 2 CD players. And then the output, 0.775 or 1.5 volts with a master, and then an equalizer that you could bypass. And then you had this preview switch. You plug the headphones in down here, and then you could switch to what you wanted to check. So you could check your levels, for example, before you open the pot. So for queuing a record, for example, put it on Phono 1 and you could back queue your record and have it ready to go. And then open the pot, one record's playing, you've queued the second record up, it's ready to go, you open the pot, hit the button to start the record, fade the other one out. Same with the line input, so you can cue everything. And then master output would just put your headphones on with its own volume pot. This thing's got a problem. It's not passing any signal. I've got a signal plugged into it right now, into tape number 2. And as you can see, there's no signal. Oh, it might help if I turn it on. Well, even if I turn it on, I had a power light here, but nothing. So we're gonna see what's wrong with this unit. I haven't used this thing in forever. I used it when I was making mixed tapes, whether they were cassette tapes or DAT tapes. I used to mix DAT tapes to listen to. Used it for that. Used it in my production studio. When I had it in my production studio, I still had turntables on it. I had a couple turntables, a couple CD players, and I had my VTR for playback. When I was dealing with 2 machines for playback for sound sync, etc., I would just play the sound off one and keep the other one closed, but then I could monitor the audio with the headphones for sound sync if I was doing 2 camera production. So I'd have VTR1 and VTR2 would come up here on the tuner inputs, and then the output of this I had my video going through an Videonics MX1, and I had the audio of this going into the record deck that was making the recording. Anyway, actually, VTR1 was over here, you see. I had it over here on, I think it was on that one there, because I had it labeled. So I had the turntable was on magnetic, and the VTR1 was on that one, and VTR2 would have been on that one, and I forget what I had on the other ones over here. But I had all the inputs, loaded up, and I had the nav output, because when I was doing recordings on high 8, I would have the ambient sound, and I would have the lavalier, and I actually modded this for the camera. As you can see, the C from cam has fallen off, but I had it set so that I could run this as another line input. So the preamp for this is disconnected inside. Should be. I had this set up as another line input so that I could take the single channel from the lav mic and run that in, so I could mix that with ambient sound and the lav. I was using an EVW 300 when I was doing weddings, and I would put the lav mic on the AFM, which was a mono soundtrack, and I had 2 shotgun mics recording on the PCM channels for stereo, so I could get the background ambient sound in stereo and have the lavalier mic that was typically being worn by the priest when I was, or official, when I was doing a wedding. I'd have the lav mic on them. And yeah, that could be interesting if I ever found some of those tapes, some of the stuff that was recorded, because I'd turn the mic on and tell them, don't mess with the switches, don't touch anything, leave it, I will control it remotely, and I would be recording everything, so we'd hear the conversations that were going on before the service started. It was pretty funny. Had one guy, though, I'll tell you the story about one guy, one wedding official. He decided that he needed to use the facilities. So rather than have me hear what was going on, he turned the mic off, and he came out and he forgot to turn the mic on. And I was waving my arms like a lunatic, pointing at his microphone, trying to get his attention to turn the mic on after the service started, and I couldn't get his attention. So I actually walked right out in front of everybody else, up to the priest, pointed at the mic, and he pulled the mic out of his pocket, and what he did on it, the microphone I had, probably still have it, it had 2 switches. One switch controlled the power for the transmitter, and the other switch muted the mic. And when he turned it off, when he turned it back on, he turned the wrong switch and had the mic muted. So I had a signal telling me that I was getting a signal, but no sound. True story. Falling apart already. Controls falling off. Shows how much wear this thing's had on it. Let's get the bottom off this unit. See why it's not working. I could take the front. I don't think I have to take the feet off on this. There should be some screws in the front, I think, as well. The story on that wedding I did way back, where it was the priest was a Catholic wedding who turned off the microphone and didn't turn it back on, and I had to kind of walk right up there and turn it on for him. At the end, when he was giving me back my microphone, he told me I was never welcome in his church again, and ripped me a new one for disrupting his service. And I said to him, what did you expect me to do? Let you do the whole ceremony with no sound? I said, you know, I said, that's why I gave you the mic and I told you don't. Four-letter word that starts with F, around with it. When I gave it to you and you turned it off. Looking at the unit here, I don't see this modified for, I've taken the mod out, I reversed it, I guess, and made this, looks like this was a mic input. This was made into a line input, but it looks like the wire's been moved back as a mic input. So I may have done that after, when I no longer use this for production. It's got some snap-on RF filtering that has been added. I think I put those on because I was getting radio stations, picking up radio stations, so I added some choke. These are like Radio Shack specials. You bought them, they were just like a snap-on choke coil. You turn a wire through them and put them on to reduce RF interference. So if I remember correctly, I was picking up AM radio stations and you could hear music playing in the background, so I put some little choke coils on there to try and keep it at bay, and it did the trick because it got rid of the noise. So I don't see, you know, offhand I'm looking to see if there's any regulators on here. That's what I'm thinking. I'm thinking maybe a regulator has gone bad, but I don't see any. See lots of little blue caps on here. I was looking to see if there was any 3-terminal regulators, and I don't see any offhand. I see bridge rectifier, which is just some diodes. This circuit board's, one of the screws has come out of this. I don't know where it went. But that board was at one time was fastened, or was it? Maybe it wasn't fastened. But I didn't see any screws fall out of the cabinet when I took it apart, but it looks like at one point this board should have been fastened. Now whether that was touching against the bottom, I wonder if this was touching against the bottom and shorting it out. Let's just hook it up again and see whether there's any sound now that it's apart. So this is my input. We'll plug this into like tape. Well, that's the output. Plug this into the amp output or the record output. They're the same. They're just paralleled right here. And we'll plug this into, say, tape 2 and just see whether I get anything. This is the equalizer board anyway, so even if this was touching, I wouldn't expect that it would do anything unless it was killing everything. But, they could have been touching the bottom cabinet, but let's just see here. Power. And I put it onto tape 2. Okay, I'm now getting some sound out of one speaker. I wonder if these switches are bad. I'm only getting sound out of one speaker, and I'm not getting anything on the meters. We're down to one channel. Well, that's better than no channels. How's the equalizer working? I hear static on both channels when I do that. I wonder if any of the other inputs work. Tape 1. Only one channel's working. Oh, the other channel's working. It's just low. Definitely that switch has got a problem. Still no meters. I'll start by removing these useless. I don't have to worry too much about interference anymore. They'll just give me some more room to work with the wires. These are sold by Radio Shack back in the day. And they did work. I remember one of my customers at work in the TV business, in their backyard, they lived on a farm, they had 1040 AM radio, music station back in the day, 50,000 watts in the backfield, and everything in the house had music coming through it. We went in and put these on everything, every speaker on their TV, stereo, everything, and it knocked it down big time. So we trace the output. The output goes, where is it? This is it here, I think. This is the output wire here, so it's coming right up to this area of the board here. There's a couple little gray capacitors here. I'm curious as to whether they are the cause of the low levels. Let's just fire the scope up and we'll take a look. They're white color capacitors here, and these particular types tended to cause problems. The nice thing about this circuit board is that I can remove it to work on it, so it's going to be relatively simple. But let's get the scope. You can do this with the old digital scope here, just because it's at hand. This will probably do this just fine, being an audio circuit. I can tell you right now, it's not the caps. Took a while to figure this one out, and those caps did get changed, and it made no difference because they weren't the fault. Take note of the time. Look at the output. This is it here, I think. Yeah, this is it here. These ones are for the meter. This one here, the brown and the red, with this zip tie around it here. These two go to the meter, and this one here is the actual audio output that feeds the outputs. A lot of time was wasted on this unit today, believe me. And when you see what caused the problem, I had a few choice words that I almost said. So as you can hear, one output is much louder than the other. It's the white wire that the output is low. If I look at it with my scope here, I had a few choice words about my digital scope too. I ended up switching to my analog scope just because it's a lot easier to see things. Digital scopes, I'm not a big fan of. Looks like I've got an offset on here too. Okay, we'll wait for the next song to play here. There we go. Am I the only one that thinks this song sounds an awful lot like Homecoming by the Yellow Jackets? Something right in this area here. Okay, this is the audio output here. If we trace the red and white wires going to this output lead, we'll see that they go to these two pins. So this is an op amp. Let's take a look at the output on it. That one's actually the meter drive. But we'll get there. No schematic, right? Good signal there. A little easier if you've got a print. Very little signal on this one. Whoops. But when you don't, because I'm not looking at the right one. How about that one? Yeah, very little signal there. Quite a distorted signal. Okay, that's meter drive. This will be the other meter drive there. That's why it's so ugly, yet my meters aren't moving, so it might be a missing voltage, like one of the supply voltages is missing, is what I'm thinking. Let's just take the meter and take a look at what my supply voltages are. I'm not showing you guys a scope, but you'll have to trust my commentary on there that the signal is distorted. Let's just take a look and see whether we're missing a voltage. I have a feeling that we're going to be missing one of the voltages, because I'm pretty sure this is going to have both positive and negative supplies. Okay, what do we got here? Minus 10 volts and 10 volts. So we have both supplies. Both rails are there. Interesting. So I'm going to look at the input. This is the input from the talkover switch here on this green wire. So that would have my left and right inputs coming up right here on this circuit board here. And I've got good signal on left and the right. And hey, I just heard it hum.
And you know why it's humming, right? Because it doesn't know the words.
It goes into this op amp here. I really dislike digital scopes. I really don't like them. Let me use my other scope. I find it's a lot easier to read. If we look at my Franken scope, I say that because it says it's a 2465B, but someone's told me that the 2465B has different buttons and controls on it. I don't know. I had this scope donated to me, so it could be two or three different scopes put together to make one, as far as I know. But I just used it for signal tracing. So here's the good channel. As you can see, I've got good signal. This is the input. On my other digital scope, the other input looked good, but on this one you can see that the one channel, this is the white wire coming off of that green coming off of the switch, it's much lower. But yet on my digital scope, they looked almost the same. but you can clearly see on this scope an instant feedback. That's why I don't like digital scopes, because there's always a delay. They're not as fast as an analog scope. And maybe for some things they'll do the job, but I'm going to look at the input. We're going to look at the input to that switch now. This is the talkover switch. So look at the good channel as well as the bad channel. So there's the good channel, and here's the bad channel. So the problem is prior to this switch, because that's the signal going in. And if I were to just bridge the two of them together, I should hear the signal pop up. So let's just short the left and the right together, and I should hear the signal pop up, which it does. I'm just using my I'm just using the points of my snips to put the two of them together. So what I've done by doing that, this is the state we're at. So I just did this. This is the talkover switch. I just took my right to short the two of them together. So what that tells me is that the problem is not on this board. This board is fine. This is the phono preamp and mic preamp here, and this is the audio output. This board is fine. The problem is back further than that board, because obviously the input is bad coming off of this other board, which is, it is fed. Where is it fed from? I'm just looking to see. Oh, it might needs to be on this board, because I know it's good from this stage back, but it looks like the other wire that feeds into that is this one here. And this one is, where's it feeding from? It is feeding from, oh, it's feeding from down here on the mixer board, looks like. So if I scope,
It's a quad op amp, so the signals go through that op amp, go down to the mixer board, and then come back.
yeah, it's bad. It's bad here. This side is bad. This side is good. I'll show you the scope. This is where having two cameras running would be beneficial. There would just be more work for me to edit it after the fact. But here is the good side, right? Good, solid, good, nice signal. And there is the bad side. See? We're listening to the bad side, by the way. I only have one channel plugged in. If I plug the other channel in, so I'm listening just to the bad side, which is this side here. So let's just trace this back and see where it goes. It's connected to, it looks like it's connected to all the pots. Okay, I'm tracing it back. This is to the output level switch, where you select 0.75 or 1.5 volts. Good signal there, good signal there. Lower signal there. And there's a control, which it was control here too. Good signal there. Low signal there. I wonder if I bridge these two together, whether it comes up. This is the left and the right. I wonder if it's that stupid switch. There's this. I wonder if that switch is causing all this trouble. There's a switch, and there's also a control here too. There's a control here as well on the master. Still distorted though. And the meters aren't working. On tracing the signal, everything seems to go south right in the area of this little op amp here. So there's basically, I would say, 4 capacitors, 6 capacitors in here. Little 2.2 at 25 volts. I'm going to just try changing these 2 here out. These 2 are in the signal path that feeds back to the mixer. Or feeds, actually it feeds in from the mixer, but feeds back to the master control. This one feeds, this cable, this connection here goes down here, which feeds to the master output, goes through that switch network for the voltage output, and then into the master fader, back through the master fader, through the equalizer here, and then back into the board here. So they feed out from the faders, they feed into here, then they feed back, and then into the master. That's kind of a confusing circuit. These are 2.2, 25 volts. Let's just try changing these 2, and possibly even these 2 over here, these 2 brown, or these 2 gray colored caps. These will be in the power supply for this op amp. Typically, though, you wouldn't think, if it was one of the power supply filters, it's going to affect both channels equally. And then these are the output ones. So input caps, output caps, and power supply. Let's just change these 4 here, just for the hell of it. 2.2 at 25 volts. I should have plenty of 2.2 at 25 volts. A whole box of them here. Oh, that pad lifted. Or was it? Yeah, that pad lifted. That's probably the problem right there. It's probably a hairline crack right on that pad. I wonder if that was the fault. Interesting. We'll change those 2 first, just for the hell of it. We'll try these 2 first, and then see what this sounds like. And now that pad lifted when I was removing it, so obviously that's directly in the signal path. So if that wasn't making a good connection, love these cheap circuit boards. I'm going to take this wire, take it right over to that jumper wire. Same goes for the other one. That might be all that was wrong with it, was that pad was lifting. In fact, the cap is probably fine. It's probably just that trace was lifting. We'll do the same for this one here. Take this trace right over to the edge, and then fire this thing up and see whether the sound is fixed. No. Not bad. So let's do the other caps, the other 2, and we'll see if that changes anything. I'll just snip off the excess here. The other 2 are these ones right here. One there and one over here. That's one. For that matter, I could even be lazy and just mount it on the bottom, which I think I will. Just because I know it's going to piss somebody off. Hey, it's my mixer, okay? I don't care. The less I have to touch the circuit board, the better. As it's not a real good quality board, if you know what I mean. It's pretty sad. Definitely on the output. Okay, let's try it now. Will that fix it? Nope. Still low compared to the other channel. See? Well, look at this circuit board. That's after pulling the parts out. It's like the solder wasn't even fused. Look at this. You can see the copper here. I pulled that cap out, and there's copper right there. I bet you it's a bad connection. I bet you if I resolder this board, this thing will work. Because I've changed all 6 of these caps here in this output circuit for both channels. And I bet you the output's still going to be low. But I bet you if I redo these connections, it'll fix it. This has got to be one of the worst boards I've ever seen. Yeah, it's still low, you see. The other channel's much stronger. But we know it's in this area here. I'm just going to redo these connections. Shut off the power, of course. I'm just going to reflow these connections here and see whether I can restore this unit. I've changed, say, all the caps that are in the circuit that's affected. In fact, this one here, I thought that was the trace that came off, but that might not be. That might be the copper that's still there. Just the solder wasn't stuck to it. Let's just see if that's actually got any copper here at all. Well, what do you know? It's just it wasn't soldered. Let's just redo this thing. This is a mess. This whole board is just an absolute mess. If you guys are wondering where this thing was made, well, it was made in Taiwan. I believe that's what it said. Taiwan on the bottom of it. This is the meter amp, this one. I remember the meters aren't working. Still low. So it's not that. I'll keep looking. Look at this board. Look at how bad this board is. Look at this. Yeah, you think that's where our problem might be? Looks really bad. I may have to bridge over all this just to try and get the connections through, because that one's just completely open. See that? The trace is completely gone. This is, I think, where our problem is just this board is so bad. I'm scared to even touch it, because you just look at it and traces are just peeling off. It's so thin. Yeah, it's just terrible. This circuit board is just atrocious. See, if this was a paid job, this would have been not fixable a long time ago. I wouldn't even attempt to do a job like this for a customer. I'd just say, throw this thing in the garbage. I don't care how much money you want to throw at me to fix this thing. It's not going to happen. Just because you do one thing to this and you've got half a dozen other faults that have just cropped up on their own. So this is a quad op amp. So we've got 4 amplifiers and 2 power rails, positive and negative, through pin 4 and pin 11. Okay, let's take a look and see where they're getting the proper power. So, be careful where I put that meter, break it from the weight of it. So, pin, what did I say, pin 4 and pin 11. So, one of them is pin 1, 2, 3, pin 4, right there. Plus 2.5. Pin 11 is minus 4. So we've got our voltage getting to the chip. Although our positive voltage, yeah, plus 5, okay, it's got the right voltage. It's got our plus 5. Oh, wait a minute, down to plus 3. What the heck? It was plus 5. Anyway, our chip's getting its voltage. That's important. And of course, I changed the 2 caps that feed the power supply for the chip. And from what I can see, these 2 are for the right channel, and these 2 are for the left channel. Yep, crappy circuit board all the way around. Here we go. Watch this. Right there. Bloody connections. This circuit board is falling apart just to look at it. There is the fault right there. Damn. I spent so much time on this bloody thing trying to find this stupid fault. It's going to shut it off and do that connection. I'm not even going to worry about the meters here. I think the meters are jammed on it is what the problem is. But let's just fix this one here. This resistor is not soldered down. Okay. Now let's see how the levels look on both channels. Yeah, that's more like it. That's more like it. Ah, man, I spent so much time on this thing today just trying to find out why it wasn't working. And it's just piss poor circuit boards, which was common in the early 80s on crap made in China and crap made in Taiwan. You know, people complain and say that the stuff made in China is junk. Well, the stuff made in China today is actually pretty good. The early stuff left a lot to be desired with these really bad circuit boards. It's not that this thing was abused, you know. I mean, some people do abuse their mixers. You know, they're taking them out to gigs and stuff, and they're getting thrown around. This mixer, for its entire life, I think they missed that screw. But the factory over here doesn't look like there's ever been a screw even attached there, does it? All these other screws are glued down, but I don't know. Anyway, as I say, it's not like this one ever was, you know, being hauled around to gigs or anything. This mixer sat in my studio, mounted on a rack. You can see where it was screwed down. It was mounted on a rack, and it never moved. It was left in one place. It was wired once, and it sat there for many, many years. I never moved it. And even when I stopped using it, it was working. I packed it away, and it hadn't been touched for years. And I went to haul it out to hook it up for something, and it didn't work. So then I packed it away again. So yeah, it's now it's working. Oh, one of the meters is working. Let's see here. Check the meters out. You know, the meters themselves have got a problem. They're mechanically jammed. This one here, if I give it a tap, it'll probably go down. Right? The meters are sticking. I don't know if this got dropped or something. Maybe that's what happened. Maybe this thing, when it got packed away, it may have fallen over. That's always a possibility. That would certainly explain why the circuit board was like it was with the cracks in it like that. And that may have been what happened, because, as I say, when I took this out of service, I haven't used this since I went to nonlinear editing. So I took it out of service and I put it in storage, and it was in a box. And I guess it's possible that the box may have fallen over, or something may have bumped it, and maybe that's why. I mean, these meters here, obviously, they worked before. Now they're jamming, so obviously it's something mechanical with the meter. But it's working. Both channels are working, so there we go. It's fixed. I'm not too concerned with the meters at this point, because it's a mechanical problem. I don't know whether I could do anything to fix them or not. Oh, one of them's not working because the wire's broken off, and I can see that right here. Check this out. Bet you if I solder that wire back on. What a joke. Wires falling off this thing. That's that's the reason why one meter's not working right there. It's not connected. We'll fix that. See if that fixes that meter, and then maybe it's just the one that's sticking. But the soldering on this thing is atrocious. Like, literally, connections just fall apart just to look at them. They just fall apart. I know you don't really want to touch this thing anymore, and I have to, because every time I touch anything, something else breaks. Okay, let's see if that meter, that one meter that wasn't working, let's see if it's working now. still not working. Yeah, the reason the meter's not working is because the meter is shot. It doesn't deflect at all. If I apply like 1 volt to the one that's kind of sticking a bit, but you'll see if you look down here, you'll see the little magnet, the voice coil will kick. You see, right? This is like 1 volt, and do the same on the other side. Nothing. So that meter is shot. So forget the meter. Not too worried about the meter. Meter is a bonus. Doesn't work, but the unit now works. So I changed those 6 caps, unnecessary caps to change. It wasn't the caps. It was a fault. It was the connections on the board here. Crappy circuit board. See? Both channels now. Nice. So I'm going to put this thing together while I'm ahead before something else breaks on it, because, as I say, just looking at this thing, the circuit board falls apart. Terrible design. You might be wondering why I even bothered to fix this thing. Well, it's not that I needed it, it's just I was looking for something to do. And this was sitting there, and I knew it didn't work, so I figured it might be something worth taking a look at to show you guys what goes on inside one of these mixers. And again, it wasn't, I mean, we can call it cheap. We can call this cheap. But when I bought this thing, and I bought this thing, 40 years ago, it had a lot of use. I used to use it, as I say, for mixing my custom tapes. But I paid a lot of money for this thing. Like this thing was probably, it was probably $200 or $300 when I bought this, which might not seem like a lot of money, but in 1980 it certainly was. Okay, there it is back together. EQ. Talk over. Okay, thanks for watching. We'll catch you in the next one real soon. Bye for now.